In this video, you will be learning how to derive the Pythagorean identity using similar triangles. So you're going to start out with a right triangle whose hypotenuse is 1, and the short leg is labeled A and the long leg is labeled B. So first you're going to find cosine theta. The cosine ratio is adjacent leg over hypotenuse, and here the adjacent leg is A and the hypotenuse is 1. And A divided by 1 just gives you A. And then you're going to substitute that back in right here, and you get A equals cosine theta. And next you find sine. The sine ratio is opposite leg over hypotenuse. Here the opposite leg is B, and you put that over the hypotenuse, which is 1. And then B divided by 1 just gives you B. And you substitute that in, and you get B equals sine theta. So next you're going to draw your altitude. And the altitude just splits this hypotenuse into two different sections, and you get two similar triangles, here and here. Then you're going to label the first section X and the next section Y. And then you bring those two triangles down here. So with this first similar triangle, we know that this short leg equals Y, and the hypotenuse equals cosine theta. So we're going to compare the short leg with the hypotenuse for each triangle. So for the original triangle, we know that the short leg is cosine theta, and you're going to put that over the hypotenuse, which is 1. And then for this triangle, we know that the short leg is Y, and we're going to put that over the hypotenuse, which is cosine theta. And then you're going to cross multiply, and you get Y equals cosine squared theta. Then you're going to do the same thing for this triangle over here. And for this triangle, we know that the long leg equals X, and the hypotenuse equals sine theta. So we're going to compare the hypotenuse and long leg values. In the original triangle, the hypotenuse is 1 and the long leg is sine theta. So the proportion for that is going to be sine theta over 1. And in this triangle, the long leg is X and the hypotenuse is sine theta. So you're going to cross multiply, and you get X equals sine squared theta. Now that we know our X and Y values, you can plug them in back up here. So we know X equals sine squared theta and Y equals cosine squared theta. Since the original hypotenuse equals 1, it's true that sine squared theta plus cosine squared theta equals the hypotenuse, which is 1. And that's how you derive the Pythagorean identity using similar triangles.